Hi guys, welcome to day 1 of lesson 8.5. We're going to get started. We're talking about recursive rules in this lesson. So I defined explicit rules and recursive rules. An explicit rule is a rule that gives a sub n as a function of the term's position number n in the sequence. So although I didn't call them explicit rules in the earlier lessons, when we were talking about arithmetic sequences and writing a rule, a sub n equals a sub 1 plus the quantity n minus 1 times d. And for geometric, a sub n equals a sub 1 times r to the n minus 1. Those were explicit rules because we were finding the term based on the number, the n value, which was the position of the term in the sequence. Okay? So we're going to now talk about recursive rules. A recursive rule is a rule that gives the beginning term or terms of a sequence, and a recursive equation that tells how a sub n is related to one or more preceding terms. Okay, so we do have rules to follow when writing a recursive rule arithmetic. It's a sub n equals a sub n minus 1 plus d. And geometric is a sub n equals r times a sub n minus 1. So the way you're going to read this or think about it is to get to the next term, you take the previous term and you add a certain value. To get to the next term, you take the previous term and multiply it by some value. All right, I'm calling this the previous term because if n is whatever term we're referring to, like let's say for instance n sub 5, or excuse me, a sub 5. If a sub 5 is the fifth term, then a sub 5 minus 1 would be a sub 4. So to get to a sub 5, I'm just using an example, you take a sub 4 and you add a certain value. So to get to the next term, you take the previous term and add the common difference. For geometric, to get to the next term, you take the previous term and you multiply by some constant ratio. Okay? So to start, it says, write the first 6 terms of each sequence. We're just practicing getting used to this notation before we write them ourselves, okay? So they're giving you the beginning, right? It says a rule that gives the beginning term or terms. They're giving you the beginning term of the sequence. So they're using a sub 0 equals 1. So this right here, that is the first term of our sequence. All right, we need to find the next 5 terms because they asked for a total of 6 terms. Here's term number 1. We need to find the next 5 terms. So a sub 1 is going to, maybe I'll write it underneath the rule, that might make more sense. A sub 1 is going to equal a sub 1 minus 1 plus 4. Okay, just plugged in 1 for the ends. So a sub 1 is going to equal 1 minus 1 is 0. A sub 0 plus 4. Well, I know what a sub 0 was. It was given. So a sub 1 is going to equal 1 plus 4. So a sub 1 is going to equal 5. Okay, so the first term is 1. I just found the second term is 5, right? That's my second term. Now I need to find my third term, okay? So a sub 2 is going to be my third term. So I'm going to plug into this formula again. It's a sub 2 minus 1, 2 minus 1 plus 4. 2 minus 1 is 1, so it's a sub 1 plus 4. Well, what is a sub 1? A sub 1 is 5. So it's 5 plus 4 to get a 9. So I just found that a sub 2 is equal to 9. That is your third term. All right. Now I have to find the fourth term. Let me erase these. So a sub 2 is the third term. A sub 3 is going to be your fourth term. A sub 3 is equal to a sub 3 minus 1 plus 4. 3 minus 1 is 2, so a sub 2 plus 4. A sub 2 is 9, so 9 plus 4 to get 13. So the fourth term is 13. Now I need to find the fifth term. The fifth term is going to be represented by a sub 4. So a sub 4 is equal to a sub 4 minus 1 plus 4. Remember, I said to get to the next term, you take the previous term and you add 4. So you're taking the previous term, 13, and you're adding 4, okay, to get 17. All right, so a sub 4 equals 17. That is my fifth term. Now I'm going to take a shortcut for the sixth term. I'm not going to use the equation. A sub 5. If each time you're just adding 4, adding 4, adding 4, adding 4, right? Because it's arithmetic. So if each time you're just adding 4, I know I'm going to have 21. Okay. Now for the next example, it's really the same thing, just the notation is different, okay? And actually I think it makes a little more sense. It was a little confusing since they defined the first term as a sub 0 because we're so used to the sub notation representing the term's place, right? Because that's what we did with explicit. So this one kind of makes more sense because f of 1, that represents the first term. The first term of the sequence is 1. So this again says to get to the next term, you take the previous term and you multiply by 3. All right, so again, this is your first term. So f of 2 is going to be my second term. So to figure that out, I'm going to use the rule. F of 2 is equal to 3 times f of 2 minus 1. Well, what is 2 minus 1? 1. So it's 3 times f of 1. And what is f of 1? Well, it was defined as 1. So 3 times 1, which is 3. So the second term is 3. Okay, to get to the third term, f of 3 is going to represent our third term. And using the rule, 3 times f of 3 minus 1. 3 minus 1 is 2. So f of 2. Well, f of 2, what we just found out was 3. So 3 times 3 gives you a 9. So f of 3 equals 9. Okay. To get to the fourth term, f of 4 is going to represent the fourth term. So using the rule, 3 times f of 4 minus 1. 4 minus 1 is 3. So 3 times f of 3. F of 3 is defined as 9, so substitute that in. 3 times 9, which will give you, oops, I didn't even finish it over there, 27. Now, you probably, again, are noticing the pattern. You probably can stop using the rule at this point. Again, it says, the rule tells me, to get to the next term, I take the previous term and I multiply by 3. So 1 times 3 is 3. 3 times 3 is 9. 9 times 3 is 27. And you can continue in that way to find the next two terms are 81 and then 243. 81 and 243. All right. So let's move on to the next problem. Okay, so for the next example, example 2, the directions are going to be write a recursive rule. And we actually have 4 different problems within this one. So I'll probably do A and B, erase, and then do C and D. So we have 3, 13, 23, 33, 43 ... and B 16, 40, 100, 250, and 625. Okay. All right, so think about what we need in order to write the rule. Think about what information you were given in the last set of problems, okay? You were given the beginning term of the sequence, and then you were given the rule. And the rule involved, it included either the common difference, if it was arithmetic, or the common ratio, if it was geometric, okay? So let's first determine what kind of sequence this is. Is it arithmetic or is it geometric? Okay, so you're going to look at the terms and ask yourself, am I multiplying or adding to get from one term to the next? All right, and hopefully you can see that we are adding. It's plus 10 each time. So plus 10, plus 10, plus 10, plus 10. Okay, so from this, I can gather that my first term is 3 and my common difference is 10. Okay. So the way you write the rule, you first give the first term. A sub 1 equals 3. That is the first part of writing a recursive rule. Then, you can use a semicolon. Then you're going to say, to get to the next term, a sub n, you take the previous term. Well, the previous term is always a sub n minus 1. That's the term before a sub n. And what do? You add 10 each time. So plus 10. And that is your rule. Okay, that's all you have to do. All right, for the next problem, identify if it is arithmetic or geometric. Okay, you can tell since the numbers are growing quite quickly, it's not increasing by the same value. It's not arithmetic. So I'm multiplying by something. What am I multiplying by to get from one term to the next? You're multiplying by 5 over 2. Times 5 over 2, times 5 over 2, times 5 over 2, and 5 over 2. And remember, to get that 5 over 2, you can take 40 over 16 and simplify, or 100 over 40 and simplify, or 225 over 100 and simplify. Okay, you'll get 5 over 2. All right, so since it is geometric, again, the two pieces of information I need to know are the first term, which is 16, and the R value, which is 5 over 2. To write your recursive rule, you start by stating the beginning term of the sequence, which in this case is 16, and then you give the rule. And for geometric, it's going to be a sub n. To get to the next term, you take the previous term and you multiply by r. It really doesn't matter if you put r on the end or the beginning. It doesn't really make a difference. They have it here, so I'll follow the rule. So it's 5 halves, and then a sub n minus 1. And that's it. All right, so remember, I'm following this rule for geometric, that rule for arithmetic. Okay, let's try 2 more. All right. So, this is C, same type of problem. 1, 1, 2, 3, 5. Comma ... And then D is 1, 1, 2, 6, 24. Okay, so when you look at these, do they look arithmetic or geometric? They are neither, but they actually are special patterns that I'm going to explain. The first is known as, sorry on my device. The first is known as the Fibonacci sequence, okay? Where it's beginning with the third term, and then each term is the sum of the previous 2 terms. Okay, so beginning with the third term, look at the third term. Each term is the sum of the previous 2 terms. So this is the sum of those two terms. And this is the sum of the previous two terms. And 5 is the sum of the previous two terms. Okay, so that's known as the Fibonacci sequence. So I'm going to say not arithmetic. Oop, spelling it wrong. All right, so not arithmetic or geometric. This is the Fibonacci sequence. Okay. So your first term is 1. Your second term is also 1. All right. Now, the next term is the sum of the previous two terms. So that's where you actually begin to write the rule. All right. So a sub n is equal to a sub n minus 1 plus a sub n minus 2. We'll think about that for a second. A sub n minus 1 plus a sub n minus 2. So think of a sub 3, the third term. A sub 3 is equal to a sub, well, 3 minus 1 would be 2, the second term, and a sub 3 minus 2 would be 1, this term. So if I'm thinking about the third term, this is saying the third term is equal to the second term plus the first term. All right, and that is the rule for the Fibonacci sequence. The next one is also not arithmetic or geometric, but it is another special pattern, and it's a factorial numbers. All right, so again, we're going to say not arithmetic or geometric. This is the factorial numbers. And we talked about factorial in the last chapter, right? If I'm saying 4 factorial, that's 4 times 3 times 2 times 1. Or 10 factorial is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay? So, a sub 0 is equal to 1. A sub 1 is equal to 1 times a sub 0. A sub 2 is equal to 2 times a sub 1. A sub 3 is equal to 3 times a sub 2. Okay, to give you a look at the pattern. So the rule for the factorial numbers, now I ran out of room, let me erase this, is a sub 0 equals 1. A sub n is equal to n times a sub n minus 1. So those are just two special patterns to be aware of, but I'm going to have you mostly looking at arithmetic and geometric sequences and coming up with their recursive rules. Okay? We just have one more problem for today. All right, for example 3, we're going to write a recursive rule for ... a sub n equals negative 6 plus 8n, and b, a sub n equals negative 3 raised to the 1/2, or times, I always say that, times 1/2 raised to n minus 1. Okay. So basically, I'm giving you an explicit, remember explicit rules? Those are the rules we first started with in this chapter. So I'm giving you an explicit rule and asking you to write it as a recursive rule. Okay? Well, think about the information you need in order to write a recursive rule. We need to know the first term, the beginning of the sequence, and you need to know either the common difference or the common ratio. Okay? So let's actually start with geometric because that one's faster. This is geometric. All right, if you remember the explicit rule for geometric, it's a sub n equals a sub 1 times r raised to the n minus 1. So looking at the explicit rule, you should be able to gather that the first term is equal to 3 and the r value is equal to 1/2. So that is all you need in order to write your geometric recursive rule. To write the recursive rule, you tell me what this sequence begins with, beginning term, a sub 1 equals 3. And then you tell me to get to the next term, you take the previous term and multiply by r. So it's a sub n equals 1/2 times a sub n minus 1. For the arithmetic, it's not really a lot more work, but we're going to want to probably find the first two terms or the first one term and talk about what the common difference is, okay? So if I wanted to find the first term of this sequence, I'm going to substitute 1 in for the n. So it's 6 plus 8 times 1. So I'm going to have 6 plus 8 to get 14. Okay, so I know my first term is, I'm sorry, I'm looking at my answer key. I'm like, why did I not get the right answer? I missed my negative. Put that negative in there for 6. It's negative 6 plus 8. Erase that. I lost my negative. So that's going to be a 2. Double check, make sure. Yeah, 2. All right, now if you can't, and you might be able to, maybe you look at this and you know what the common difference is, and I'll talk about that in a second by looking at the rule, but if you're not sure, find the second term. The second term is equal to negative, don't lose your negative this time, plus 8 times 2. That's negative 6 plus 16, that's 10. Okay, so if the first term is 2 and the second term is 10, hopefully now you can see that your D value is 8. Okay, well, I could have known that by looking up here. Because remember, for your explicit arithmetic, it's a sub n equals a sub 1 plus n minus 1 times d. So the problem is, this doesn't match exactly because we distribute the d, we can distribute the common difference in. But the d value is always going to be the coefficient of the n. So your common difference is always going to be the coefficient of the n. But if you forget that, find the first term, find the second term, and then look to find what the common difference is. Okay? So I know my common difference is 8. I know my first term is 2, so now I can write my recursive rule. My first term is 2. And then I'm going to say, to get to the next term, take the previous term and add the common difference. So a sub n equals a sub n minus 1 plus 8. And that is your recursive rule. All right, that is it for day 1. Day 2 is very, very short, but I'll see you back here for that later on. Bye.